Okay, what we have here is a situation where an helicopter is rising vertically with a uniform speed of 14.7 meters per second, and a wheel drops off when it's 49.0 meters from the ground. So just let me underline what information is given. Uniform speed of 14.7 meters per second, 49 meters from the ground. And what we have to find is the time taken for the wheel to reach the ground. And the second part of the question asks us to find the velocity at impact. Okay, now let's see what we can do in this particular situation. Now, this question involves vertical motion. All right, so vertical motion involves movement up or down. So vertical motion, you can have movement either up or down. Oops. Or down. And we are dealing with vector quantities. Velocity, displacement, acceleration. These are vector quantities. So when we're dealing with vector quantities that can be either up or down, we need to determine which direction is considered positive and which direction is negative. I've chosen upwards to be positive and downwards to be negative. The choice is yours. Okay, you can choose upwards as negative and downwards as positive also. Now what we should do is list down what information is provided to us. Now the wheel is connected to the helicopter. So if the helicopter is rising vertically with a uniform speed of 14.7 meters per second, the initial velocity of the wheel will be 14.7 meters per second, and it will be directed up. The reason why I've taken it as up is because the helicopter is rising, so it's moving upwards. So the wheel was initially attached to the helicopter before it fell off. So as the helicopter is rising, the wheel is also moving upwards with it. Now, what other information we have is that the wheel falls 49 meters because the wheel falls off when the helicopter is 49 meters from the ground. So the displacement of the wheel to hit the ground is 49.0 meters. Now, displacement is a vector quantity. So we have a magnitude, which is 49.0 meters. And the direction of the displacement in this case will be down because the wheel is falling down. So the displacement will be downwards. Okay. If you allow me to sketch a simple diagram, let me see. This hopefully looks like a helicopter to you. And here you have ground. So there's a wheel of a helicopter. Of course, there's this landing gear. So the wheel falls. So it falls to the ground a distance of 49.0 meters. Now, displacement is a vector quantity that represents the shortest line from the original position. So this is the original position of the wheel where I marked in red. And I'm marking in black the final position of the wheel. So if you were to draw a straight line from the initial position, which is marked in red, to the final position, which is marked in black, you will see your arrow pointing downwards, having a length of 49.0 meters. So this is why I've given it downwards. The other vector quantity that we need to have is acceleration. Because the wheel is falling under gravitational acceleration, it will have a value of 9.8 meters per second per second. At this level, don't use 10 anymore, use 9.8 or 9.80. And gravitational acceleration is always down because gravitational acceleration is always downwards. Now, so let us think about which equation we should be using. So let us list what information we have. We have u, the initial velocity of the wheel, 14.7 meters per second upwards. We also have displacement of the wheel 49.0 meters downwards, gravitational acceleration or acceleration of the wheel, because it's in free fall, it will be subject to the gravitational acceleration of 9.80 meters per second downwards. And what are we supposed to calculate? In the first part, we need to find the time it takes for the wheel to hit the ground. So if you look at the information that is provided to us, we have u, initial velocity, s displacement, a acceleration, and we need to calculate t. Which equation should you choose? Obviously, the only equation that doesn't involve v in it is this equation, s equals to ut plus half at squared. Now, let us substitute s, u, t, and a into this equation and see what we obtain. Now, we start with the left-hand side of the equation first. S is 49.0 meters downwards. So the value of s is 49.0 meters. Now, what will be the sign attached to it? Will it be positive? Will it be negative? Now, let us look back at our convention. We have taken downwards as negative. So s is 49.0 meters downwards. So we must assign the value of s to be negative 49.0. This is based on my choice. If I've taken upwards as negative, downwards will be positive. So this is your choice. This is your choice. Okay, you can change your choice, but if you pick upwards as positive, downwards as negative, for the entire question, you must maintain that convention. Do not change it within the question. For the next question or other questions, you can change your convention. Okay, but be consistent with your convention for one or the same question. Obviously, this is equal to u times t plus half at squared. So u is 14.7 meters per second, the upwards. So now it is 14.7 positive, okay, multiplied by t. T is what we have to calculate. And of course, plus half. The value of a is 9.80. I must put a minus sign because gravitational acceleration is downwards. And I'm taking vectors downwards as negative. This will be t squared. Okay. Now this is a quadratic equation. There are a few ways you can do it. To solve this equation, you can do it online, or you're familiar with your scientific calculator. You can use your scientific calculator to solve. And on solving, you will get two values for t. One will be negative 2.00 seconds, and the other one will be 5.00 seconds. Now, the minus sign here indicates that this is before the wheel fell off. This happened. Minus sign, minus time actually means that the event occurs before your timing started. So this is not physically possible for our situation. We need to ignore this value and we take this value because we're looking at time after the wheel fell off. Okay, so your answer will be 5.00 seconds. So what do we need to do next? We need to find the velocity of the wheel at impact. So we need to calculate the velocity of the wheel at impact. Now, the velocity at impact, or v, will be the value of the velocity when the wheel hits the ground. From here, we should be able to see that the time for impact is 5.00 seconds. If you recall from the earlier part of the question, it takes 5 seconds for the wheel to actually hit the ground. So we need to find the value of v at 5 seconds. Is there any other information we can draw from this question? You should recall that the initial velocity of the wheel was 14.7 meters per second upwards. The value of its acceleration will be 9.80 meters per second. Downwards, so recall that anything that falls towards the Earth is undergoing free fall, and free fall acceleration is 9.8 meters per second, which is the Earth's gravitational acceleration. So let's look at the information we have. We have t, we have u, we have a, and we need to find what is v. Okay, can you figure out which equation you should use or must use? Well, the only equation that will give us anything is this one. Okay, let us substitute what we have. So of course v, something that we need to calculate. This is equal to u, 14.7 meters per second upwards. So it will be plus 14.7 meters per second. The reason I've written a plus sign here is because you should recall our convention. I'm taking upwards as positive. So any vector value that is vector quantity that is directed upwards must have a positive sign in front of the value. So plus a is 9.80 meters per second. It's directed downwards, so I must put a minus sign. So recall the minus sign here is because downwards is taken as negative. And then t is 5.00. So if you were to calculate your value of v, you'll get a minus 34.3 meters per second. Do not be put off by the minus sign, because the minus sign just indicates the direction of the velocity. So now let's look back at our convention. Again, note that downwards is negative. So your v will be 34.3 meters per second downwards. So this is your answer.